Unit 5C Study Guide. Number 1, describe the transformations of each function to the parent function f of x equals absolute value of x. So if you look at part A, what's your h? It's 1. But remember your vertex, okay? Your vertex is negative h, comma, k. What that means is whatever your h is, it's going to be the opposite of. So what's the opposite of plus 1 for h? Negative 1. And k is 0 because there is nothing outside of your absolute value. So the transformation that occurs here is that you will go left 1 unit. Okay, so this is a horizontal shift 1 unit to the left. Okay, and that's what you have to write. For part B, it's minus 1, so it's the opposite direction. So you will go to the right 1 unit. Okay, so this transformation, and this is what you have to write, your transformation is a horizontal shift to the right 1 unit. Okay, and again, you could always double check with your vertex. The opposite of negative 1 for your h, and k is 0. So it shifts. Okay. Part C, if you notice, there is no h inside the box with your x, or the absolute, and your k. Finally, we have a k, a number out here. Okay. So your vertex is definitely going to be at 0, comma 2, and the k really just sent you up 2 units. Okay, so compared to the parent function, you did a vertical shift up 2 units, and that's what you would write. Okay, part D, if you notice, k is now negative 2, so your new vertex is going to be at 0, because there's no h inside the box, comma, negative 2. So this is a vertical shift down 2 units, and that's what you write. Okay. Now, if you notice at E, we don't have an h inside the box with x, and we don't have a k outside, and that's because your vertex is at 0, comma 0, very much like the parent function, except the only difference now is your a. Okay, your a is now negative. Okay, all the other times before they were positive 1, and you know, multiplying 1 is basically invisible. Okay, so you have a reflection. So what you would say is this is a reflection and I know some of you kids call it the flip, right? The flippity flop. So you can also call it the flip, but I'm pretty sure your teachers are going to be saying reflection, and they'll be looking for that in their test. So again, their word is always stronger than mine, unless you are my kid, all right? Unless you are my student. So reflection across the x-axis. Okay. If you take geometry next year, that's going to be pretty significant. You're going to see that for your first couple months. All right, number 2, solve each equation. So let's get the box all by himself, the absolute. So let's get rid of a minus 8. How do you get rid of a minus 8? You plus 8. And just make sure what you do to one side, you do to the other. Then you're going to get everything in the box to the left, to the left, to the left, all by itself. Negative 7 plus 8 is 1. You have the box all by himself. So now just write your disjunction, which again is an or statement. So you have x over 8 equals negative 1, or x over 8 equals positive 1. Now, don't worry about fractions. All right, how do you get rid of a dividing 8? Well, you multiply by 8. Make sure what you do to one side, you do to the other. So make sure you distribute accordingly. Notice how your process is very much the same for both disjunctions. The only difference is the number on the right. Okay, so you're going to get x equals -8, or x equals +8. Okay, now I want you to go ahead and try part B on your own. Okay, and then just come see me, let me know if you did it right or not. And seriously, that's for you. Okay, so I'll probably make this an assignment. So definitely try B, see if you can do it. Part C, solving absolute values with the solutions, but one positive, one negative. Ooh, so we have to use part B as a counterexample, so might as well just solve it anyways. So scratch that. I want to make sure you understand what C is talking about, so I'll do B. Use the subtraction property. See, you think you have it all planned out. Nope. All right, so you have the absolute value all by himself, okay? And what's 11 minus 8? That is 3. The box is finally all by himself. So set up your disjunction, which again is your OR statement. So you have x minus 3 equals -3, or x minus 3 equals +3. Notice how the process is the same to solve for x. The only difference is the number on the right. Okay, so these cancel out, but again, the only difference is the number on the right. -3 plus 3 is 0. Okay, or x equals 3 plus 3, 6. So again, notice how the process is the same. We both use the addition property to get rid of the minusing 3, to subtracting 3, and we got two different answers. Okay, and that happens. All right, so when we're solving for an absolute value equation, if you're going to be, one of the reasons you have whatever's in the box, whatever's in the absolute, equaling the negative version and the positive of that number. Okay, see, like they're asking, like, but one of them's positive and one's negative, and then they say why, you know, like explain. And the reason is simple. If you take your original disjunction that we start from, okay, and we go ahead and substitute. So in your situation, if you were to substitute in a 0 for x, you would get a -3, an absolute of -3, which equals 3. Now, this is how you get the disjunction, is because if you went ahead and tried the 6 for your x variable, you're going to get 6 minus 3, and that just is 3. And the absolute value of 3 is also going to be 3. Okay, that is why, because both solutions will work. They will both be true. Okay, so when you're solving, that's why we set up our disjunction. Okay, and I'm using example B, okay, to show why. So they may ask you something like that. So just be aware of the process of a disjunction. All right, going on. Number 3, solve for each equation. All right, so we have to get the box all by himself, and we also have to explain the result, okay? How do you get rid of a multiplying 4? Divide. Make sure what you do on one side, do the other. N plus 4, okay, the box, and then -8 divided by 4, -2. Now set up your disjunction. N plus 4 equals +2, or x plus 4 equals -2. Now, you can go this way, okay, if you're used to that system, but you need to realize something. Can you have an absolute value equal a negative number? You can't. So, you can spare yourself the work and simply just state no solution. And that is because And you could say since negative number inside your absolute cannot equal a negative number. Okay, and that's the definition of an absolute value. All right, let's do the same thing with part B. Mind you, this is your answer, no solution. Okay, so addition property. Let's go ahead and get our box to the left all by itself. And you're going to get 6p minus 3 equals 0. Now, if you write a disjunction, you're going to realize something. You're going to get 6p minus 3 equals 0, or 6p minus 3 equals 0. They're the same. Okay, there's no negative 0. That's why 0 is such a beautiful number to me. So if you were to solve for p, I'll use the division property. You're going to realize you're only going to get one solution. P equals 1/2. And you would get the same for here. Okay, so you would say one solution since a disjunction of an absolute value equaling 0 is only going to have one solution. Okay. All right, number 4. An organizer of a drama club wants to sell 200 tickets to their show. Their actual size or sales were no more than 15 tickets from this goal. Ooh, okay. Write an absolute value inequality to represent the situation. So, this club, they desired, 200 tickets for their show. And their sales tickets were no more than 15 tickets from this goal. Okay. So when you write the absolute value inequality to represent this situation, this would work. Okay. Now, what is the range of tickets that could have been sold? So when they're asking about range, in real life, you just basically in your head can do 200 plus 15 and 200 minus 15, and you can find your range. Okay. Now, if you did your disjunction, and I'll go ahead and create our disjunction, which is again an OR statement. You're going to have x minus 200, and don't forget, when you negate, you flip, your inequality symbol. We'll go ahead and solve. And just like how I said, basically all you have to do is really just ask yourself, well, what's 200 minus 15? Okay, so you should get 185. Okay, x is greater than or equal to 185 tickets. Okay, now your other disjunction, 15 just stays 15, so your symbol stays the same. And then add 200 to both sides. And you're going to get x is less than or equal to 215. Now, when they want a range, they want something like this. So we're talking about tickets, and you could probably use T also for tickets. That's optional, unless your teacher's like, no, X could work just fine. Remember, you can have less than or equal to 215, or you can have more or equal to 185. Okay, so this is your range. Okay. This right here, the inequality, is just a fancy way of saying 200 tickets plus or minus 15. Okay. Now, if you were to graph it, you have 185. Make sure the point is solid. Because there is equal signs here. And then 215 is right here. Make sure it's solid. And if you notice these arrows, for the 185, the arrow is going Ooh, do you see what I did? Look at that. Mr. Webb did not have his coffee. Mr. Webb messed up on his sign. Good thing I caught that. Oh, wait. No, he didn't. Silly Mr. Webb, doubting himself. Okay, just the way I wrote it. All right, so if you notice this sign right here, the arrow is pointing this direction. So you can shade from 185 to this way. Now with this way, okay, 215 is pointing to the left, like that. That's an arrow, okay? So you're going to shade in this way. So this is your range. Anywhere in this region will work for this drama club. All right, so we're going to have to solve each inequality, justify each step. So let's get the box solved by himself, and let me use a different color coding. All right, subtraction property. Get rid of that 10. Okay, make sure you mention that. Okay, subtraction property. And then you'll have 3 times your box, whatever's in the box, or the absolute. Your inequality becomes 21. How do you get rid of a multiplying 3? The division property, okay, of inequalities. Make sure you write that. So you have k plus 3, okay, the absolute value of it is less than or equal to 7. Now we write our disjunction, okay, and your disjunction is because the definition of an absolute value, because absolute values have 2 parts to it, okay, it's piecewise. So we have k plus, that's terrible k plus 3 is greater than or equal to -7. The symbol flips because it's negative. And or you have k plus 3 is less than or equal to 7. Okay, numbers stay the same, so the symbol stays the same. Use a subtraction property, and you should get k is greater than or equal to -10. Or you're going to get k is less than or equal to 4. So go to -10. It's solid, okay, because the symbol, okay, there's a victim under your alligator. And we go to 4, make sure it's solid. And so if you look here, the arrow is pointing this direction from -10. So you're going to fill in this direction from -10. If you look at 4, okay, the arrow is pointing to the left, so you shade in to the left. Okay, and that's how you do the shading. At the end of the day, I want to make sure that you've got some practice for this. So try part B on your own, okay, and then just raise your hand, let me know, like, hey, did I do this right? All right. Also pay close attention to the fact that your inequality, there's no victim under the alligator, so it's probably going to be hollow points or open points when you graph down below. Okay, so try B on your own. Raise your hand if you think you got it, and yeah, let me know. Give me some feedback. I'll walk by and double check. And part C, how are the solutions different for part A and part B? Compare and contrast the graphs of the solutions for each part. I already know that the symbols are different. Okay, so if the symbols are different, you're probably going to have open points for part B and closed points for part A. And the graphing of it might be different. So I want you to try to reflect on this today. All right, raise your hand, come see me, and I'll walk around making sure you're okay. All right, So try part B, then try part C, and just let me know if you're thinking right, doing it right, okay? Number 6, write the equation for each graph, state the domain and range for each. All right, so first things first, my vertex, okay? My vertex has to be at negative h, comma, k. So my vertex is down here, right? The point that the two rays launch out from. And his coordinate is at 2, comma, negative 1, right? So his equation, let's see, does he go up 1 over 1? Yeah, he does. Okay, so his a is definitely 1. So since it's not the parent function, we'll use g of x in function notation. Absolute value of x. Now remember, your h is going to be the opposite of whatever your vertex h is. So what's the opposite of positive 2? Negative 2. And k is just k, which is negative 1, which is also the same as minus 1. Okay. Domain. Domain is the x's. So as you go through all your x's, you're still going to be crossing through your rays. Your rays are just going to keep going all the way towards negative infinity and all the way towards positive infinity. So your domain here, you can just write all real numbers, okay? For range, on the other hand, remember range is your y's, okay? So as I go down, it doesn't exist. It stops existing here, down here at negative 1, okay? So negative 1, okay, it exists there, but then as you go up, it keeps existing, and it'll keep existing. See how my red line keeps crossing those rays? It'll keep doing that forever. And that's how you can write your range, okay? I'm also okay if you were to write it like this. I will understand exactly how you were thinking, okay? That would work. For part B and part C, I want you to try this, okay? I want you to try it. Okay, so notice one thing though. It's not a happy graph. It's a sad graph. Okay, so your A is probably going to be negative. Okay, wink, wink, hint. And then I want you to try to compare and contrast the domain and range. Okay, that's in part C. So I want you to try part C and B. First B, C, right? Okay. Number 7, which of the following functions answer the questions? Okay, state the transformation. Okay, so basically, what's my h? What's my k? Okay, my h, it makes me go left 2 units, right? So I shift 2 units to the left horizontally, and then my k, it makes me go up 4 units. So vertical shift up 4 units. So again, this is h, this is k. Now if we sketch the parent function and we graph the g of x, you're going to know something. So here's your parent function. I'll do this one in blue. Parent function, its vertex is at 0, 0, up 1 over 1, just like in my notes. Up 1 over 1 for my other ray. And its vertex is at 0, 0. But just like in part A, like I said, we shift 2 units to the left, 1, 2, and 4 units up, 1, 2, 3, 4. So my vertex is right here, and my A, again, looks like he's 1. So up 1 over 1, up 1 over 1. Same thing with the other ray. Okay, so this will be g of x. Okay, and the blue one is f of x, your parent function. And the vertex, again, remember whatever your h is, so it's going to be the opposite. So the opposite of positive 2, negative 2. And k is just k, so 4 is just 4. So your vertex for g of x is at negative 2, 4. The domain and range, so for domain, You can say all real numbers, okay, just like in the last problem over here, okay. And your range, on the other hand, is slightly different. Your range, if you look, it stops right there at 4, and then it just goes on to infinity. So you're going to go from, going to be greater or equal to 4, or less than or equal to infinity. Okay. I'm also okay with you writing it like this. I'll understand what you're saying. Okay. Part E, what if there had also been a reflection over the x-axis in this example? How would the question be different? All right, so how would your graph be different? So basically just remember part E is just saying, well, if A is equal to -1, instead of, you know, a happy graph, you'll have a sad graph. The vertex will stay the same, and that's probably what you should mention. Your vertex stays the same. It just reflects, okay? It reflects. So if I was to graph this, if g of x was, you know, negative, his vertex would stay the same. He just reflects. He just goes upside down, okay? And that's what you probably could mention. All right, so that was your study guide. Good luck. Let me know if you have questions. Try the problems I asked, okay? And I'll double check and walk around, make sure you're good. Good luck.